Hello guys, this video will cover Bernoulli's equations. If you're following with ENGR 205, this is video 10 of Unit 1, their video series. This is Bernoulli's equations basically allows you to get it into the form of first order linear, which is what you saw on video 9, where instead of having this equation that you see right here, the dy dx plus px y equals qxy to the n. Instead of having this y to the n here, you would just have you wouldn't have anything there. It would just be qx, and you're able to get an integrating factor mu to multiply to each term to solve from there. But now with this y to the n, that hinders you, and it's not in the right form for you to multiply by that mu. So Bernoulli's equations allowed for you to take out that y to the n and get it into the first order linear form. These are kind of vague steps that I wrote down. So you want to divide by y to the n. So you get it. So you have just qx by itself. And then you substitute in v equals y to the 1 minus n, where n is this exponent you originally had there. Then once you sub that in, then you can solve the first order linear from there. I'll go ahead and do this example problem I have at the bottom here. There's one step, there's the first step I've already done. I've already divided by y squared from each term, which implies 1 over y squared dy dx plus 1 over xy. Yeah, the first step that was already there because I forgot to erase it after I did it for the first time. But to elaborate on why I was able to just go straight into doing that step is that this example problem was already in the form of y prime here, p of x, y, and q of x, y to the n. So since it was already in that form, I was able to go straight into the dividing by y squared from each term. Oops, sorry, there's not supposed to be a y squared. There's supposed to be an x squared there. There we go. So now let's substitute v in for 1 over y. The reason why I did 1 over y, because it's supposed to be v equals y to the 1 minus n, and in our case is 2, so equals y to the negative first, or 1 over y. So now I'm going to substitute that in for each y here. So then I'll have v squared on that first term, dy dx, plus v over x equals x squared. Now there's only one little problem here. We still have this dy dx. So I'm going to get rid of that dy dx. In order to do that, we must take the derivative of v here. So with respect to x, so we do dv dx, and that will equal negative y to the negative second dy dx. And this implies that dy dx will equal negative y squared dv dx. Since we're trying to get this all in terms of v, I want to go ahead and substitute that y squared in for v squared, 1 over v squared. Since the y is on top and not on the bottom, it will become 1 over v. So this right here equals negative 1 over v squared dv dx. So now I want to go ahead and plug that in. So that it becomes v squared times our substitution for dy dx, which is dv dx times negative 1 over v squared. So now we'll cancel our v squareds here, and I'll show you why that's really important in a second, or at the rest of this equation. So now we're going to get this into the form of our dependent variable prime. In this case, d is v, so we have dv dx. I'm going to go ahead and multiply this negative sign through each term so that my dv dx isn't negative. So it becomes positive dv dx minus v over x equals negative x squared. Right here is right here we need to find mu. So mu is going to be what is going to be defined as e to the integral of px dx. So our p of x is 1 over x. Sorry, negative 1 over x. But I gotta make sure you carry that sign right there. So it's going to be 1 over x. And I'm not putting my v in there because v is within the equation right here. So you can see that we just need all the function of x and not v. So negative 1 over x dx, and this will equal e to the negative natural log of x, the absolute value of it. Now I have to hit this negative sign and put it to the exponent of this x. So then that way, I can now take out this e in natural log, and this will become 1 over x. So now I'm going to multiply this 1 over x to each term in our equation that we had just a second ago. So now it becomes 1 over x dv dx minus v over x squared equal to negative x. So right here is a very, very important step, and it's important in both Bernoulli's equation and first order linear, since it is the same process after you substitute it in to be in the right form. But right here, this is the result of a product rule. So what I mean by that is that this was originally the derivative of two different equations being multiplied to each other, and we're able to reverse that. If you notice that, if you remember what a product rule is, that it's going to be derivative of one times the other plus the other times the derivative of one. Not of one, but of one equation. So in this case, we can note that in this first term, v was taken to the derivative. So v was taken derivative of, and we can integrate dv dx so that we get just v. So we know that our term is most likely v over x. We can confirm that by looking at the other term. If the first term was the result of derivative of v times 1 over x, the second one's probably going to be the derivative of 1 over x times v. So if we integrate that 1 over x squared, negative 1 over x squared, we will end up getting a positive 1 over x. I even showed it to you over here. So if we integrate negative 1 over x squared dx, we would have negative x squared dx. So if we add 1, it would become negative first, and then divide by negative first, so it becomes a positive x and negative first, which equals 1 over x. So we know it's going to be v over x. So what's that? So now how do we show that this is the reverse of the product rule? Well, show that this right here is the same as this. We have to put a derivative out front. So that's the derivative with respect to x is equal to negative x. So if we calculate a derivative, we'd get what we just had here, the result of a product rule. So now the next step is to integrate. So now we're going to integrate by integrating the dv over x. This d represents a full derivative, and we're going to take this dx and move it to the other side. So we negative x dx, and we take an integral of that with respect to x. So the full integral and a full derivative will cancel each other out. And we'll integrate this other side, and this will equal negative x squared over 2 plus some constant. Now our next step is to sub back in for y. So if we made v equal to y to the 1 minus n, or negative first in our case, we can now say that this will become, instead of v on top, it will be y on the bottom. So it'll be 1 over yx is equal to negative 1/2 x squared plus c. So big things to remember from this on Bernoulli's equations is that you need to get it into this form where you have the y to the n. you must divide by y to the n so that there is only x's on your right side of your equation, your q of x, essentially. And then you must sub in for y with this v equaling y to the 1 minus n. And then you solve from there based off of first order linear from video 9. So that's and just to really emphasize this reversing product rule in this step, that's really important because there's been several times, even knowing that I needed to do it, I would get it to it on a test and I would hesitate and I would not know what to do for like 10 minutes and I would skip it and then I'd come back to it and it would just click. But sometimes you're not always that lucky. But really reinforce this result of the reversing the product rule into your head for first order linear and Bernoulli's equation, because you will not be able to solve this entire problem without doing that. So I think I've answered all the big things for this. If you have any questions, please let me know in the comments. Please give me any feedback of any kind. If you really liked what I did or if you really hated it, I don't really care. I just want to get any kind of feedback that you have that can help me become a better teacher, YouTuber, whatever. I don't even care what to call myself. I just want to be able to spread and teach math better so that everyone can understand it more easily and everyone can be more prepared for their exams and whatnot. So thank you for watching. I really hope this helps. Good luck on all of your exams. All right. Thank you.